In this video, I want to explain what an empirical formula is and how to perform a calculation to find an empirical formula. So, an empirical formula is just like a molecular formula. So what I have written for you here, that I'm going to outline in red, is a molecular formula. So that's what a compound's formula actually would be. Now, an empirical formula would be the reduced version. So when you look at those subscripts, I can reduce all those by a factor of 6. So that would be CH2O. Now that would be my empirical formula. So the empirical formula is just a stepping stone in like a laboratory process to finding the molecular formula. It has no chemical relevance. It's just the reduced version of the molecular formula. So let's show you how to do a problem when finding an empirical formula. Okay, so there's two different kinds of problems that you can encounter when trying to find an empirical formula. So this first one is giving me percents. So when I'm given percents, the first thing I want to do, and I'm going to keep a tally here, is I want to assume that we have 100 grams. When I assume we have 100 grams, all those percent symbols turn into grams. So that's 32.4 grams of sodium, 22.6 grams of sulfur, and 45.0 grams of oxygen. Now the second thing you'll do to find the empirical formula is we want to convert to moles. Okay, so I want to convert all of these values from grams to moles. So that would be 22.99 grams to moles. That would be 1. That's 32.07 grams to moles. 1 and 16. Alright, so when I push in my calculator, those are my answers. And now for step 3, I want to divide by the smallest one. Now, what I'm doing here is I'm just trying to use a ratio to determine what those subscripts are for the empirical formula. So 0.705 is my smallest number, so I want to divide all of these by 0.705. And when I do that, I should get whole numbers. So 0.705 divided by 0.0705 is 1. And the first one is a 2, and the last one is a 4. So those are the subscripts. So my empirical formula would be Na2S1O4, which is what the answer is. So Na2SO4. So we got sodium sulfate. Alright, so this empirical formula problem is a little more difficult, but it sort of skips over that first step. So I'm already in grams, so I can just jump straight into converting them to moles once I find out what elements we're dealing with. So it says analysis of a 10.150 gram sample of a compound is known to contain only phosphorus and oxygen and indicates a phosphorus content of 4.433. So 4.433 grams of phosphorus. Now, if I take that 10.150 minus that 4.433, that tells me how many grams of oxygen I have. So 5.717 grams of oxygen. Now I have to convert these both to moles, so grams to moles. 30.97 grams to moles. 1 and then 16. Alright, and there's my answers. So now I pick the smaller one, which is 0.143, and I divide both of them by that number. And this one actually is really interesting. When I take that second one, 0.3573, divided by 0.143, I get 2.5. So I didn't get a whole number this time. So if you ever get a 0.5, that's hinting to you that all of my subscripts need to be doubled. So this 1 should be times 2, and that 2.5 should be times 2. So my empirical formula would be P2, O, 5. So if you ever get a 0.5, it's just hinting that all my subscripts need to be doubled because there isn't a 1 in the empirical formula. All right, so now the last step, trying to find out what my final molecular formula actually is, which is the one that has all the chemical relevance in a compound. So with the previous example, we found that the empirical formula was P2O5. Now, this is another number that you would have to be provided in a problem, or you would have to find by doing an experiment, but it says experimentation shows that the molecular molar mass of the compound is 283.89 grams per mole. So my molar mass is 283.89 grams per mole. Okay. Now, to find out what the molecular formula is, we're going to do another ratio. So, to find out the value, we have to multiply those subscripts by, and I'm just going to call that value x. You have to take the molar mass divided by the mass of the empirical formula. So, it has to give me the molar mass, or I find it through experimentation, so that goes on the top, divided by the molar mass of the empirical formula. So I add together phosphorus times 2 plus oxygen times 5, and I get 141.94, and when I solve that out, I get 2. So I need to get the molecular formula to double those subscripts. So my molecular formula would be P4O10. So that would be the unreduced version. That's the one that's important to me. So if you're ever asked for the molecular formula, just have one more step after you find the empirical. Okay, so this example covers all of what we just talked about. So go ahead and pause the video, give this one a try, and when you get back, I'll go through how to solve it. Okay, so it says a sample of a compound contains, with a formula mass of 34 AMUs, consists of 0.44 grams of hydrogen and 6.92 grams of oxygen, and we want the molecular formula. So I'm going to start with that 0.44 grams of hydrogen and 6.92 grams of oxygen, and I want to convert those both to moles. So I'm going to drop grams, go to moles, 116 for the oxygen, grams to moles, 1 and 1.01 for the hydrogen. So after a quick calculation, those are my answers. So I divide by the smallest one, and in this case, if you guys haven't seen already, that I get a 1 for both of those. So the empirical formula for this one is just HO. So now I have to find the molecular, so that's where the formula mass comes in. So I need to find that X value again. So I take that 34.00, and I'm going to divide it by the mass of HO, which is 17.01, and that gives me a 2. So that means I need to double the subscripts of my empirical formula. So my molecular formula, which is the answer, would be H2O2.